In these two questions, we want to find the best predicted value of the response variable. In order to do that, we need to know what is the appropriate thing to use. So our options are to either use the regression equation, and that's y hat equals whatever that is, or to use the value of y bar. And how we decide which one to use is that we're going to look at our critical values of the Pearson correlation coefficient R. So we have our value that comes from the chart. In the first example here in 31, it says 4 pairs of data yield R equals 0.942. And what I'm focused on right there is the fact that we're talking about 4 pairs of data. So I'm going to go to where n is equal to 4, and our value of alpha is 0.05. So I look to the column where alpha is 0.05, and my critical value of R is 0.950. So I'm going to put that down for R. The negative value of R is negative 0.950. So I'm going to decide which way to predict the value of Y by using Y bar if our data yield a correlation coefficient between R and negative R. And I use Y hat if we fall into either the left or the right-hand tail. So in this particular case, in question 31, we know that the value of R, the correlation coefficient, is 0.942, and that falls between R and negative R. So that means that I want to use Y bar in this particular case. So our value of Y bar is 12.75, and that would be the answer for that question. Now, in question 32, take all that out. In question 32, we have 8 pairs of data. So I look to my chart and 8 pairs of data where alpha is 0.05. Now our value for the critical value is 0.707. So I change my critical values to 0.707 and negative 0.707. And our value of the correlation coefficient is 0.742, which is going to fall in the right-hand tail. And that means I want to use Y hat in order to get my best predicted value. So for Y hat, I'm going to use the equation 55.8 plus 2.79 times the value of x, which is 8. And when I calculate that, I get 78.12. So that should be my solution there. So that's how we decide which one to use and how we solve those two problems that look very similar but are actually different in how you proceed.